Hey, Chem students, time to try our first lesson with my super pen. So if you see in front of you, you're going to see three different chemical equations. You can balance chemical equations using trial and error, and that's absolutely fine, but sometimes in AP Chem especially, we will run into equations that are really, really difficult to balance trial and error. You know, they'll have coefficients of like 18 and 23 and 25 and things that just are really, really hard to balance that way. So I'm going to refresh your memories on the mathematical way to balance equations. For some of you, this may be new, so you want to pay special attention. For others of you, this is just a review. All right, so the first thing you're going to do is everywhere where there's going to be a coefficient, you are going to place a variable. So I'm going to call this A, B, C, and D. You can really call it whatever you'd like, but usually A, B, C, and D is quickest and easiest and fastest. So then you're going to make a list of all the types of elements that are present in the equation. So we have carbons, we have hydrogens, and we have oxygens. I'm going to start by just looking at the carbons. So if you look at the first compound, the one we consider the A compound, there's only one carbon in that compound. So I'm just going to call that 1A or A. In compound B, there are no carbons. So I'm not going to put anything that has a B with it in my little variable equation. Whenever we go across the yield sign, we're going to put an equal sign. On the next side, on the product side, we have one carbon in C. So I'm just going to write one C, and no carbons in D. So carbon's represented by the equation A equals C. And we're going to forget about that one now. We're going to move on to hydrogen. So there are 4 hydrogens in A, like so. There are none in B. There is a yield sign, so we'll put an equal sign. There are no hydrogens in C, yet there are 2 in D. So I'm going to put 2D. Don't worry about reducing it or anything like that. It's just going to take care of itself when we do the last part of the problem. As for oxygen, there's none in A. There are 2 in B. Yield sign is an equal sign. There's 2 in C, and then there's 1 in D. So since these are on the same side of the chemical reaction, I'm going to connect them with a plus sign. So oxygen is represented by 2B equals 2C plus D. Okay, so you've written all your variable equations, but you can't solve until you know one of your variables. So we're going to make a list. A, B, C, and D, those are our variables. So what we're going to be solving for. We're going to always assume that A equals 1. A may not equal 1, and we'll deal with that in a few minutes when that comes up, but always assume that A equals 1 and go from there. That will work almost all of the time when you're doing your problems. If it doesn't, I can show you how to deal with it, but assume A equals 1. So if A equals 1, and you look over to this first equation, if you plug in A is 1, then that means C is 1. So that was pretty easy. If you plug into this equation here, then you will have 4 times A would be 4 equals 2D, so D is going to be equal to 2. And then for the last one, we have 2B, we don't know B, equals 2 times C, so C is 1, so 2 times 1 is 2, plus D, which is 2, so 2B equals 4, so that means B is equal to 2. And those are your coefficients. So this should be a 1, this should be a 2, this should be a 1, and this should be a 2. And you can always double check by adding up both sides. Okay. So that's that first one. Let's go ahead and try the second one. I'm just going to go through this one a little bit faster, but I'll still talk through it. So we have A, B, C, and D. Making a list of my compounds, I have carbons, I have hydrogens, I have oxygens. For carbon, there's 2 in A. There's none in B. There's 1 in C, and there's none in D. For hydrogen, there are 4 in A. There are none in B, none in C, and then 2 in D. And for oxygen, there are 2 in B, 2 in C, and 1 in D, like so. So that is our set of equations. I'm going to say A, B, C, and D over here. Remember, we're always going to assume that A is equal to 1. So if A is equal to 1, then C is equal to 2, based on this equation here. Going to this next equation, if A is 1, then that means D is 2. And the last equation, 2B equals 2 times C, which is 4, plus D, which is 2. So 2B equals 6. 2B equals 6. So B is equal to 3. So you have 1, this will be a 1. Remember, you don't have to write the ones. This is a 3, this is a 2, and this is a 2. Simple as that. Now, we will run into times when A does not equal 1, like in this example here, so let me show you how to deal with that. Just an extra little step. So I make my A, B, C, and D. I make my list of elements. So I have aluminum, I have hydrogen, I have chlorine. So aluminum is A, or in A we have 1 aluminum, so I'll say A. And then I yield sign, and then there's 1 aluminum in C. For hydrogen, there's 1 in B, and there's 2 in D. And for chlorine, there's 1 in B and 3 in C. And then we're going to make our list, A, B, C, and D. So if A equals 1, C equals 1. For this next equation, for this equation here, we can't actually plug into that one yet because we don't have B or D. So I'm going to jump down to the third equation. I don't know B, but I do know C is 1. So B equals 3 times 1, and that's going to make my B3. So then when I come back to this second equation, I've got 3 equals 2D. So when I solve for D, I'm going to get 3 halves. We all know we can't have a fraction as a coefficient. So the way that you're going to deal with that, if you do end up with a fraction, is you're going to go ahead and multiply all of the coefficients by the lowest number possible to get rid of the fraction. So in the case of 3 halves, that multiplier would be 2. So I'm going to have to multiply them all by 2. You can't just change 1. So this is going to be 2. This one's going to be 6. This one's going to be 2. And then the 2's here cancel, so this ends up being a 3. So that gives us the coefficients of 2, 6, 2, 3. Okay? If you have any issues or problems with this method, especially if you're new to it, please make sure that you go ahead and ask me before school, after school, during class. I'd be happy to help.